Okay, so last time, from the last video, I promised to teach you how to sketch the graph of the example that we discussed previously, which is the, I don't remember the equation. Just a second, I have to check. So RT is, so RT is TT square. Now you can see that even though the vector function a bit simple, quite simple, but it's end up to be quite complicated of expression, and it is something you need to spend long time to produce or to obtain the unit normal, right? Okay, so now this is time for us to sketch the curve. Okay, we already, okay, we already sketched, we have a quadratic, right? So now we just I just revise. So x is equal to 2, so this is parametric equation, and then y is t squared, and then transform into Cartesian, we have y equal to x squared. Okay, now we sketch the graph. Here we have a quadratic. That's a quadratic. Okay, like that. On y-axis. Okay. So now sketching the graph, sketching the curve, and sketch the unit tangent. Okay, so now we list all the result that we've obtained where we at t equal to 1. So at t equal to 1, we obtain the position vector, which is when t is equal to 1, and the position vector now is 1, 1. Okay, so we also already compute the tangent vector. So the tangent vector in t we obtained previously, we have 1 over square root 1 plus 4t square, and then 2t over the square root of 1 plus 4t squared. Okay, so when we replace t at equal to 1, we obtain that we have 1 over square root 5, yes, and then 2 over square root 5. And then we also already obtained the n. Okay, so now the unit normal vector in general. Okay, after quite long step, finally we can have a bit simple form. 1 plus 4t square 1 over 1 plus 4t square. Okay, and then at t equal to 1, we obtain minus 2 over square root 5 1 over square root 5. Okay, and maybe we want to know the tangent vector, maybe just so our r prime, so r prime t is 1 to t. Okay, then we replace 1, 2. Okay, so now you have to sketch. Okay, so in order for you to obtain the unit tangent and unit normal, you cannot directly plot the point of this particular value of x and y. Okay, because this t happens at the point of when the t is equal to 1. So where is the t equal to 1? So you have to look at your position vector. Where is the location of t equal to 1? Is around at this point, which is in terms of before you plot you label the position vector, you must be able to obtain the point which is when t is equal to 1, you obtain 1, 1. So now let's say this is the point. So this is 1 and this is 1. So that is located at the point of 1, 1. But that is just a point, but you have to label that particular position vector. So here you have to provide this, and this one is the vector when t is equal to 1, which is given by 1, 1. So that is the correct way. Okay, this is the correct way to label the position vector when t is equal to 1. So I already teach you this before, okay, from the previous videos. Okay, so now where is your t? So based on our understanding, we know that unit tangent has to do with just like tangent line. So meaning that we can expect, okay, what we can expect, the tangent vector or the unit tangent should be in this form. But we haven't know that yet. Okay, then you have to refer back to your value of t here. So it's just our expectation, okay, from our understanding. It can be that way because it depends on the direction of the particle moving. The particle is moving, right? Remember that t, whether this way or this way. So it depends on the whatever you have to plot after this. So that is just our expectation. Okay, now how can you provide that? Okay, so you already obtained the t at t equal to 1. So now for the sake of, okay, now I put here for the sake, just for sketching, yeah, for the sake of sketching. So sketching means to plot. So to plot, I mean this, we plot the point first. So you have to add this point with the position point. I mean you have let's circle, you have this one for x component, and you have to add with this one because your starting point, your point is starting, okay, your point is starting at 1, 1, not 0, 0, because you're now stop right over here. So imagine this just like your origin. Okay, so that's why your component here, when you have compute, must be added by the your position now. Okay, so now I would say that to plot, so I don't know how to write that. So the component, I would say that, so now I would say for the component x, you have to add 1 plus 1 over square root 5. That's for x. And then for y, you got 1. So 1 plus 2 over square root 5. You have to add with this one. Okay. So now you have to evaluate because you want to find out the location. So you have to just compute this. You cannot leave this in this form because we do not know in decimal form what is the value of this. So you have to compute. Okay, so for the x component, when you add this, we will get approximately 1.45, and this one, you evaluate this, is approximate to 1.9. So this is for the sake of sketching to plot. So our position, our t unit tangent, will be in this particular point, just for the sake of plotting. But the real of t is actually this one. Okay, so now we find out where is the point 145 and 1.9. So let's say this is 2, and then this is 2. Okay, so where is that point? Where is the point 149? What we have that 145. So maybe around here, because the other one is 1.9, somewhere here, I think. Okay, so now that is your point, which is based on your t. So now how can you plot that? You know that now your t is point to here, point here. From here, you are over there, okay. Now your t is point to here, so then you take a ruler, so it should be something like that. Okay, so that is your t at t equal to 1. How can you get this arrow? From the point that you calculate just now. Make sure you have to add with this particular value your location now at 1 1. Okay, understand? Similarly for n, also the same. For the sake of sketching, you have to add 1 and 1. So here, for the x component, 1 plus, so what is the value of n that we got just now? Negative 2 over. So minus 2 over square root 5 for x component. For y component, 1 plus 1 over square root 5. And then when we evaluate that, so your n will be at 0.1 and your y component 1.45. Okay, so now we want to locate where is the point on our sketching. Okay, so 0.1, so, and then 1.45, so around here. So now, what color that I can use now? Okay, I'm using, so that is your n unit normal at t equal to 1, and you can see that they are perpendicular. So yeah, even though we don't refer to the, actually you can expect before you obtain their point, I mean the point of t and the point of n, from the property of the t and n. So if you know that this is t, so we know that, and this is point inside, right? So this is a turning point, so point inside, so we can expect that our n should be here. But now, because it should be based on your calculation, so it should be matched. Okay, so if you got the I mean your calculation is not the same as what we are expected, so meaning that you compute something wrong, so then you have to double check. Okay, so that what I'm talking here, your understanding, your result of, I mean your understanding and your result that you obtain from the calculation should be matched. Okay, so that is the way you can sketch the n and t. Alright, so that is for the unit tangent and unit normal. How can you sketch that? Should be starting at where is your location, at which t. Let's say they ask you to evaluate the unit normal and unit tangent at t equals to 2. So you have to for the sake of sketching, plotting, you have to start at that particular point at the position vector. It's not from the 0 0. If you ignore, you don't put the one here, and the one here, so your sketching is completely wrong. Okay, so now maybe you want to know, how about the tangent vector? Okay, as we understand from our previous lesson, so the direction of the tangent vector, so t is a unit tangent, so the direction of tangent vector is the same as unit tangent, but it should be longer. Okay, so you can, maybe you can check. So now we have this one, 1 2. So for the sake of sketching, so our tangent vector, now you have to add 1 plus 1 and 1 plus what we've got just now. Oh, sorry. where is, okay, 2t, 2. You got 2. So 1 plus 2. So you got 2, 3. So where is 2, 3? When I was sketching. 2, 3. So it should be somewhere here. And you can see that your just a second, I have to erase that. Where is my black? Okay, this one. Okay, so that would be our tangent vector at t equal to 1. They have the same direction as unit tangent, but the magnitude should be longer, because we know that the unit tangent, the magnitude is always equal to 1. So our understanding now is can be confirmed by the calculation that we obtain here. Okay, so hopefully you understand. So this is favorite question. So normally this is, I would say, this is a complete set of questions in exam. So I hope that you really understand with this example. Okay, I'm not saying that this example, this particular question, this particular R will be asked in the exam, no. But the way, the step, the question looks like it's the same as this one.